Imagine trying to drink from a fire hose,
Right.
but instead of water, you are just getting hit with pure, unfiltered information.
Which sounds exhausting.
It is. Specifically, picture trying to process, let's say, 6,000 terabytes of data
Wow.
every single day. That is the current reality of the U.S. Argus ground surveillance system.
Yeah.
We are talking about a 1.8 gigapixel camera and 368 individual sensors collecting over 40 gigabytes of information
Per second.
per second. It's
Wild. It's a volume of information that the human brain simply did not evolve to comprehend. I mean, we just aren't wired for it.
No, not at all.
And yet, this is the baseline for modern military intelligence. To understand how they even begin to handle this, we're pulling from a really fascinating stack of sources today.
We've got defense think tank reports, current doctrine from the U.S. Army War College.
Right, and some really deep technical analyses on AI and multi-sensor fusion.
Welcome to today's deep dive. If you're joining us, our mission today is to explore intelligence fusion and big data in combat.
Exactly.
We really want to figure out how modern militaries prevent commanders from drowning in this ocean of data.
Right, because it's everywhere.
We're going to look at how satellite imagery, intercepted signals, and artificial intelligence combine to create actionable battlefield information.
And we will also look at the strategic side of this. We have some incredible real-world examples, including an operation that achieved a staggering 94% AI-assisted targeting accuracy.
94%.
Right. The underlying theme across all these sources is that modern conflicts are defined by what experts call algorithmic warfare.
Algorithmic warfare.
Yeah. Basically, the side that manages their data best wins.
So the information overload problem is the core hurdle here.
Right, that has to...
Because in a combat scenario today, data is pouring in from low Earth orbit satellites, surveillance drones, ground-based acoustic sensors.
Even open source intelligence.
Right. Public social media platforms. You could put thousands of analysts in a room working 24 hours a day, and they wouldn't even scratch the surface of 6,000 terabytes.
They'd be paralyzed, which is why the U.S. Army War College doctrine emphasizes a total structural shift in data management. They call it the condensation distillation framework.
Condensation and distillation.
Right. It treats data not as a static resource that you just, read, but as a raw material that has to be refined.
Okay, that makes sense.
So the first phase, condensation, tackles the deeply unstructured nature of the data.
Right, because, a satellite photo, an intercepted radio transmission, and a text-based logistics report are completely different formats. They don't naturally talk to each other.
That is the massive hurdle. To fix it, militaries are moving away from traditional databases and utilizing modern graph and vector databases.
Graph and vector databases.
Yeah, a graph database maps dynamic relationships. So say you have a person of interest, a specific vehicle, and a known safe house. The graph database doesn't just store those individual items. It mathematically maps the connections between them.
Oh, wow.
And then vector databases take this even further. They allow systems to search by context rather than just a keyword.
So what does that look like in practice?
Well, if a commander is looking for, say, supply chain vulnerabilities, the vector database can pull an image of a damaged bridge, a thermal scan of stalled trucks, and a text report about fuel shortages.
Because it recognizes that all three of those things represent the same contextual concept.
Exactly. It understands the context.
But even after condensing the data, giving it a structure a machine can manipulate, you still have a commander staring at a massive, albeit organized pile of information.
Right. And that brings us to the distillation phase.
Distillation.
This involves deploying AI agents to autonomously scan that structured data. They are programmed to answer commanders' critical information requirements, or CCIRs.
So the humans aren't running manual searches anymore?
No, not at all. The AI is continuously filtering the live data stream against the commander's specific operational needs, extracting only the vital insights.
Okay, think about this in the context of a really complex multi-domain operation.
Yeah, paint a picture.
Let's say a commander is trying to coordinate an advance of ground troops. But there's a sudden spike in enemy drone activity, combined with intercepted radio chatter, and a radar detects movement near an air defense battery.
It's chaos.
Right. Without this framework, the commander just gets dozens of conflicting, panicked reports from different units.
Just noise.
But with a condensation distillation framework, the AI synthesizes all those data points and pushes a single distilled alert. Something simple like, enemy air defense repositioning to counter-advance, recommend holding ground forces and deploying electronic warfare suppression.
Exactly. The AI does the cognitive heavy lifting. It does the pattern recognition. And this concept applies directly to you listening, regardless of your industry.
Oh, completely.
Whether you are in finance, healthcare, logistics, success relies on achieving optimal information asymmetry.
Optimal information asymmetry.
Right. You want to absorb vastly more information from your environment than you transmit, but you absolutely need an automated layer to filter the noise. You only want to interact with the insights that actually drive decisions.
So, digging into the mechanics of how the computer actually sees these patterns to generate those insights, it relies heavily on multi-sensor fusion.
It does.
Because it is easy to just say the computer looks at a camera,
Yeah.
but combining totally different types of sensors into a single understanding is incredibly complex.
It is massively complex. The recent Senjo's report breaks this down into 4 distinct processing levels.
Okay.
It starts at the signal level.
Which is essentially just dealing with the physics of the data collection, right? Like cleaning up interference before the computer even tries to look at an image.
That's exactly it. That's the foundation. You enhance the raw signals to cut through background noise or atmospheric interference.
Right.
And once you have clean signals, you move up to the pixel level.
Okay, the pixel level.
This involves merging different types of imagery on a microscopic scale. So you take a standard optical photograph and perfectly overlay a radar scan.
Just aligning them perfectly.
Right, aligning them pixel by pixel to create a single composite image.
And then the system has to actually figure out what those pixels represent.
Exactly. That is the feature level.
Yeah.
The AI scans that composite image and extracts specific recognizable shapes, edges, or textures.
Like identifying the geometric outline of a missile tube?
Or the specific tread pattern of a tank in the mud.
Wow.
And finally, everything funnels into decision-level fusion. The algorithms weigh all those extracted features, the merged pixels, and the clean signals to make a conclusive determination about the object in the environment.
Because relying on a single sensor type is just a massive vulnerability. Every sensor has a blind spot.
Every single one.
Optical imagery provides really high-resolution visuals, but it is entirely defeated by a cloudy day or nighttime. Infrared detects heat signatures, allowing you to see a vehicle engine running in pitch black. But modern militaries use thermal camouflage to hide those exact signatures.
Which is where synthetic aperture radar, or SAR, becomes critical.
SAR.
Yeah. SAR can physically pierce through cloud cover and certain types of foliage. It doesn't rely on light or heat at all.
So when you layer SAR, infrared, and optical data, and then you cross-reference that visual picture with signals intelligence, intercepted enemy communications.
You gain a totally comprehensive understanding. You don't just see a camouflaged metal box.
Right.
You know the box is an armored personnel carrier. You know its engine is warm, and you know the exact radio frequency the occupants are using to communicate with their command.
It's incredible. And this combination of multi-sensor fusion and AI distillation fundamentally collapses the traditional kill chain.
Yes.
The kill chain being that sequence to execute a strike, find, fix, track, target, engage, and assess.
Historically, moving through those steps required really painstaking manual coordination between different analysts and operators.
Just a lot of phone calls and emails.
Yeah. But we are now seeing platforms like Palantir's Maven Smart System and Anduril's Lattice automate massive portions of that sequence.
And the time savings are profound.
Unbelievable. Processing satellite imagery to confidently recommend a strike previously required around 12 hours of manual human analysis.
12 hours?
The Maven system reduces that to less than a minute.
Less than a minute.
Yeah.
Taking a process from 12 hours to under 60 seconds is a complete paradigm shift in operational tempo.
It changes everything.
And Lattice takes this a step further, right? Yeah. By forcing entirely different hardware ecosystems to talk to each other autonomously.
Right. During demonstrations, Lattice has successfully linked F-16 fighter jets, MQ-9 Reaper drones, and ground-based Army howitzers.
So the AI finds the target, tracks its movement, and recommends the optimal weapon system to engage it based on proximity and payload.
Exactly. The AI orchestrates the entire battle space, leaving only the final lethal decision to a human operator.
The theory is impressive, but looking at actual combat deployments shows the true impact of this.
Oh, definitely.
The reports highlight Operation Sindoor. This was an operation executed by Indian forces in 2025.
Yeah, this is a perfect example. They utilized an AI system that fused 26 years of historical conflict data with live intelligence streams from drones, ground sensors, and satellites.
But the most fascinating element of that operation wasn't just image recognition.
Yeah.
They deployed an indigenous AI weather forecasting model, and it analyzed atmospheric conditions 200 kilometers inside enemy territory.
Which is brilliant because the environment plays a massive role in long-range ballistics.
Right.
Calculating the exact real-time effects of wind shear, temperature fluctuations, and air density on a missile's trajectory is a highly complex computational problem.
Because if a crosswind shifts 20 miles away, your ordnance completely misses the target.
Exactly. But by fusing that real-time predictive weather data with their targeting AI, they achieved a 94% accuracy rate in neutralizing adversary missile launchers.
94%. And they managed that level of attrition without ever physically crossing the line of control.
Right. The commanders involved described this integration as a massive force multiplier. It tightened their decision cycle, provided real-time validated intelligence, and optimized their resource deployment.
Ukraine's Delta system offers another really interesting angle on this.
Yes, Delta is fascinating.
It's a cloud-based ecosystem that functions as the digital backbone of their military operations, utilizing specific platforms called Visa and Avengers.
And those platforms are ingesting and processing thousands of live video streams simultaneously.
Thousands.
They automatically detect, classify, and tag enemy equipment in real time, creating this dynamic, living map of the battlefield. But honestly, Delta's most significant achievement is its interoperability.
Right, because getting different military systems to share data is notoriously difficult.
It's a nightmare. They all use proprietary software and totally different data formatting standards.
But during a major NATO exercise, Delta successfully integrated with 15 different command and control systems from 10 different nations.
Which is huge. The AI managed all the complex data translation in the background, proving that these systems can securely fuse intelligence across a massive multinational coalition.
Without requiring everyone to use the exact same hardware.
Exactly.
So understanding how the technology works on the ground naturally leads us to the broader strategic picture.
Right.
Because this has triggered a massive global algorithmic arms race.
Mm-hmm.
And the sources outline how different global powers are adopting vastly different doctrines to achieve an edge.
It's a completely different approach depending on where you look. China's approach, for instance, is defined by their military-civil fusion strategy.
Military-civil fusion.
Yeah, they actively dismantle the barriers between their commercial technology sector and their defense apparatus.
So advancements in AI developed by major commercial entities like Baidu and Tencent are directly funneled into the People's Liberation Army.
Right. And they also place a very heavy emphasis on cognitive warfare.
Okay, what does that mean in this context?
Well, they aren't just using AI to guide missiles. They are using it to analyze social trends, shape public perception, and automate disinformation campaigns at a massive scale.
Yeah.
Their stated strategic goal is to achieve total global AI leadership by 2030.
Now, Russia is utilizing a totally different approach, what the reports call pragmatic battlefield adaptation.
Yes. They lack the deep native commercial AI infrastructure of China or the US, so they rely heavily on open-weight AI models.
And just for anyone unfamiliar, an open-weight model is an AI where the underlying architecture and the pre-trained parameters are freely available for anyone to download and modify.
Exactly, as opposed to a closed proprietary system like ChatGPT.
Right. So Russia takes these open-weight models, which are often originally developed by Western or Chinese researchers, they strip them down and rapidly adapt them for immediate practical combat applications.
Like automated drone targeting or basic computer vision?
And they are testing these adapted systems directly in the conflict in Ukraine.
The reports also note a developing dynamic between Russia and China, describing it as a loose AI axis.
Interesting.
China supplies the deep technological infrastructure and advanced hardware, while Russia provides a real-world testing ground in a high-intensity conflict zone.
And just to impartially lay out the U.S. strategy based on these sources,
Yeah.
the United States approaches this through dual-track commercial partnerships.
Right. The Pentagon realizes it simply cannot match the development speed of the private sector.
So it creates consortiums, like the partnership between Anduril and Palantir. The strategy is to foster fierce competition among tech companies while ensuring the military doesn't become locked into a single vendor's proprietary ecosystem.
But that approach definitely brings its own set of challenges. The U.S. military procurement process is notoriously slow and bureaucratic.
Very slow. And there are also deep political debates regarding the military's reliance on commercial tech billionaires.
Right. Furthermore, there are significant data sovereignty hurdles when the U.S. tries to deploy these integrated, cloud-based intelligence systems alongside European allies who operate under strict, differing data protection laws.
So let's bring this back down to the tactical level for a second.
Okay.
A cloud-based, hyper-connected AI system sounds incredible in a pristine environment. But warfare is inherently messy. What happens in a DDIL environment?
DDIL.
Yeah, military terminology for denied, disconnected, intermittent, or limited. If an adversary jams the communication spectrum, or a unit is operating deep in a subterranean facility with zero connectivity, does this entire multi-billion-dollar AI infrastructure just shut down?
That is the exact problem. A system that requires a constant connection to a massive cloud server in Virginia is a critical vulnerability. Adversaries will always target the network link.
Right.
So the engineering solution to the DDIL problem is edge computing. Instead of sending the data away to be processed, you process it right there on the edge of the network, locally on the device itself.
But a ruggedized laptop in a Humvee doesn't have the processing power or the memory capacity of an Amazon server farm. How do you run complex AI on a local microchip?
You utilize companies like EdgeRunner AI. They specialize in model compression and hyper-specialization.
Not a compression.
Yeah, they take these massive, large language models and systematically shrink them down. They do this by fine-tuning the model exclusively on military doctrine, tactical field manuals, and specific operational parameters.
I see. The AI doesn't need the billions of parameters required to write poetry or generate recipes.
Exactly.
It only needs to know how to analyze a radar signature or recommend a flanking maneuver.
Right. By stripping away all the general knowledge, the model becomes small enough to run entirely on-device for special operations teams.
And operating on device provides a massive security advantage. It entirely eliminates the risk of data interception in transit because the data literally never leaves the physical laptop or the vehicle's internal network.
It's totally contained.
But while edge computing solves the connectivity issue, this level of automation introduces some really severe risks. We have to look at the vulnerabilities of the system itself, starting with data poisoning and cybersecurity.
Yeah, this is terrifying.
When you rely on a vast network of interconnected sensors, every single sensor is a potential entry point for a hack or an advanced persistent threat.
If an adversary cannot jam the network, they will try to corrupt it. Data poisoning involves subtly altering the information feeding into the AI.
So, like spoofing a radar signature.
Or manipulating thermal output so that the multi-sensor fusion algorithms completely misinterpret the environment.
And if the AI is fed poisoned data, it will confidently draw the wrong conclusion, perhaps identifying a civilian convoy as a hostile missile battery.
Which is a nightmare scenario, and that leads directly to the risk of hallucinations.
Right. Anyone who has interacted with commercial AI chatbots knows they occasionally fabricate information entirely.
They just make things up.
In a commercial setting, it's an annoyance. In a combat setting, if an AI hallucination invents a threat that does not exist, and a commander acts on that false intelligence, you could trigger a catastrophic strategic escalation.
And the risk of hallucinations is heavily magnified by a psychological phenomenon known as automation bias.
Automation bias.
This is the human tendency to over-rely on automated systems. When a commander works with a system like Maven or Lattice, and the system is correct 99% of the time, analyzing data thousands of times faster than the human brain cognitive drift occurs.
The operator gets complacent. I mean, if you are 12 hours into a stressful shift and the machine tells you to authorize a strike, the human inclination is to trust the machine rather than painstakingly verifying the raw intelligence.
Exactly. You stop being an analyst and start being a rubber stamp.
Which is terrifying.
That cognitive trap is why modern military doctrine, as well as international humanitarian law, strictly mandates meaningful human control.
Meaningful human control.
Right. The AI is utilized as a highly efficient staff officer, capable of synthesizing data and presenting options, but it cannot possess moral agency. A human being holding legal and ethical accountability must remain in the decision loop to authorize any application of lethal force.
The technology has to serve the commander's intent, rather than dictate it.
Exactly.
Well, looking at the scope of what we've covered today, modern militaries are attempting to drink from the fire hose of information by fundamentally altering how data is processed.
They have to.
Through the condensation and distillation framework, they are structuring thousands of terabytes of data and using AI to fuse satellites, radar, and signals intelligence into a cohesive, real-time understanding of the battlefield.
And you can really see the applications for your own field as you're listening to this.
Oh, absolutely.
The capacity to condense chaotic data inputs and distill them into actionable insights is the defining challenge of the modern information age. Achieving that optimal information asymmetry is what separates agile organizations from those that are just constantly reacting to the noise.
It redefines decision-making at every level. But I want to leave you with a final scenario to consider, based on the rapid advancement of these systems.
Let's hear it.
We've explored the massive difficulties inherent in ensuring our own AI systems are safe, reliable, and kept under meaningful human control. But what happens on a future battlefield when highly autonomous black box AI systems from opposing nations interact with each other in real time?
Wow.
If neither side fully understands the deeply layered, nonlinear ways their own algorithms arrive at conclusions, how do we ensure that two competing intelligence systems don't misinterpret each other's data streams,
Right.
instantly escalating a minor misunderstanding into a massive conflict in the milliseconds before a human operator even realizes what is happening?
It's a chilling thought.
It is reality the developers of algorithmic warfare are going to have to face very soon. Keep exploring, keep questioning, and we'll catch you on the next deep dive.